You're listening to the Seen and Solved podcast brought to you by Hubbard-Hall. Better results, less chemistry.
So welcome to this edition of Seen and Solved. I'm your host, Tim Pennington. And today we're talking to a true celebrity in the world of cleaning, Mike Valenti, Hubbard-Hall's Director of Technology. All right, let's talk about bath maintenance. That seems to be something, once you get a line dialed in and everything's going really well.
Comparing and contrasting the two types of cleaning, right? So in solvent degreasing, your bath maintenance is minimal, right? You're doing maybe two things. You're looking at probably the acidity of the solvent. So solvents can go acid depending on the types of lubricants and the type of solids. So there's a acid acceptance test that typically gets done. And then really the only other thing you're doing in a solvent system is we tell people to watch the boiling point of the solvent. If you start seeing it rise, then that means there's a lot of soil built up and it's changing the boiling point of the solvent. And those things happen slowly over time, and they don't have major impacts immediately. We're talking months to years sometimes before people start seeing those things. In aqueous cleaning processes, a lot of times the chemistry, there's a couple of things going on. The chemistry itself is constantly being drug out of the tanks let's go back to our part with all these little geometry. So all these little areas are going to carry the cleaner solution out of the tank or out of the chamber or whatever the type of equipment is. In solvent degreasing, we're recycling that solvent all the time. We're losing very little. In aqueous cleaning, we're always pulling cleaner out of the tank every time we run a barrel of parts or a rack of parts. So as the volume of cleaner gets reduced, you have to add volume back to the tank. And so if you have to add water back to the tank, you also have to add cleaner back to the tank. So maintaining that bath chemistry is very important to make sure that the chemistry is at the right level, to make sure we have the right amount of constituents in the bath. Because if you don't, and the cleaning tanks get too lean and the chemistry gets too dilute, then parts aren't going to get clean. And so there's a number of ways that we do bath maintenance, but they tend to require at least daily intervention, doing simple things like titrating a sample to see if doing conductivity tests. Now, a lot of these things can be automated. We can automate tank filling simply, but that doesn't mean you can get away from doing these tests of the chemistry in the tank to make sure the chemistry is where it's supposed to be. So when you go to aqueous cleaning, just realize there's a lot more that you have to pay attention to as far as the tanks. And then I talk about rinses. So the opposite happens in the rinses. Now we're looking for chemistry to build up in the rinse tanks. So you have to do maintenance on your rinse tanks. You have to check your rinse tanks. How much of the cleaner and the contaminants am I dragging into my rinses? And how long before my rinses are so dirty, I'm just putting clean parts back into dirty water. So there's also maintenance you have to do on the rinse tanks themselves to make sure that your rinses stay. So it's not just the cleaner baths, but it's the rinses too that you have to do maintenance on. So, and you have to do this on an ongoing basis. You can't go for a week and not check your cleaning process line, right? And then the other major thing that happens in an aqueous cleaning bath that doesn't happen in solvent is, in solvent cleaning, the soils dissolve into the solvent. They don't separate, they're incorporated. In aqueous cleaning baths, soils have basically three things that can happen to them. They can float to the top, they can sink to the bottom of the tank, or they can emulsify into the bath, okay? So those are the three mechanisms or the three things that can happen in these soils. So if soils float to the bath, if it's that type of soil or that type of cleaner soil system, you have to be able to remove that floating contamination off the tank. So you may need to skim the tank. You may have to put separator systems so that you can separate the oil. Because what happens if you have an oil sheen or a layer of oil on top of a tank with clean parts underneath it? When you draw them up, they're going to be dirty, right?
They'll be dirty again, yep.
If it's an emulsifying system, those are formulated to hold a certain amount of oil. And once they hit saturation, they're saturated. If you don't remediate the bath or replace part of the bath or all the bath, the oil is going to start to split. So there are things we can do. We offer a filtration technology to filter oils out of emulsified cleaner baths. So splitting and emulsifying oils, there are mechanical processes that you should consider and put in place to remove the contaminants out of the bath, and that makes the bath last longer. Now, if the soils sink, that's a problem. Those are a lot more difficult to deal with. And there are certain lubricants that are known to sink to the bottom of a aqueous cleaning tank, and historically, those types of lubricants are cleaned in solvent systems. So as people try to transition those types of systems to aqueous, they're going to run into this issue of those types of lubricants sinking to the bottom of the tank. So that's always a big challenge.
We talked with your colleague, Robin Deal, a lot about wastewater. So how does the aqueous cleaning impact a facility's wastewater system versus solvent cleaning?
Yeah, so I like to say this, and people look at me cross-eyed. I say that solvent cleaning is actually greener than aqueous cleaning. And the reason I say that is whether you're doing vapor degreasing or now a lot more people are looking at vacuum degreasing, you're constantly recirculating fresh solvent in the system. The most modern degreasing machines lose very little solvent out of the system, okay? So your waste only comes when that solvent bath finally becomes so saturated with oil that you have to call someone to come in, pump that out, and haul it away, okay? With aqueous cleaning, I like to say every gallon of cleaner solution eventually becomes a gallon of waste, right? Because we're dragging the stuff out, it's going into the rinses. So people have two choices. They're either pumping all that spent cleaner solution or dirty rinse water to a waste treatment system and treating that as waste, or they're paying someone to come in and pump all that material out and haul it away. So that's a cost that people don't think about because you can't dump those things down the drain. In a lot of municipalities now, you can't even dump the rinse water down the drain. We have customers that are in areas where they're told specifically they cannot discharge anything without it being waste treated. So if you're a facility that doesn't have a waste treatment system, and now all of a sudden you're generating all this aqueous waste, your two choices are put in a system to treat the waste or pay to have someone haul this material away. And so that's a major added cost. And it's something that people don't think about because if they've been solvent degreasing, it's been simple, right?
Right.
Someone comes and pumps it out every 6 months to a year. And outside of that, they really, really don't have to worry about their waste profile. And as soon as you become a waste generator, now you have to have someone staffed that is licensed to handle waste generation. So it adds a lot of complexity.
Permitting and inspections and those type of things.
Right. And the days of just dumping things down the drain are over. So it's getting tighter and tighter. And some of the aqueous chemistries in particular are getting the regulations on how much can be discharged are getting tighter and tighter. So it makes the waste treatment process even more important that they aren't discharging these chemicals. That's where sometimes even the rinses can become problematic if you're discharging too much of a particular, like a phosphate, for example, right? They just keep tightening down these chemistries tighter. So then that starts to limit the chemistries that can be used, right? So you can see how it builds on itself. It makes things a lot more complex. So waste is a big consideration if you don't have a system in place already. Now, if you're a big facility, you're already treating waste, then you have to start thinking about what's in these cleaners and how's that going to affect my waste treatment? Is there something in the cleaner that's going to cause me to have a problem? This is where Robin will come in and make sure that's not a problem that they can treat properly. But that also happens all the time. Somebody decides, okay, I'm going to put this cleaner in, and I'm just going to dump the dirty cleaner baths to my waste treatment. Next thing you know, they've got a treatment problem. If someone's been solvent degreasing and they've been treating other things, and then one day they decide, oh, it's no big deal, I'm gonna dump my cleaner tanks and start treating those, then all of a sudden, they can't treat the waste anymore. So that's another thing they have to think about is what's in this chemistry that I'm about to dump to my waste treatment system, and how's that going to affect it?
And like I said, the numbers are getting lower and lower.
Numbers keep getting lower and lower.
Let's talk about equipment. You mentioned earlier on about equipment, how important it was. So what are some considerations when putting in an aqueous system?
So it really depends on the parts and throughput. Everybody thinks I'm just promoting solvent cleaning. Hubbard-Hall in general, we are agnostic to it. But again, one of the things about solvent degreasing is that the cycle times are much shorter, right? Because you're dealing with one chemistry, you're dealing with one black box, so to speak. So your cycle times are short compared to aqueous cleaning. Why? Because I'm literally doing everything in one step. I'm cleaning, rinsing, drying, everything's sort of happening at once, parts are done. So if you have really high throughput needs, right, and you go from solvent to aqueous, you may need to have a bigger footprint of equipment, or you're typically going to have a bigger footprint of equipment for aqueous degreasing than you would for solvent degreasing, right? Because you got to put so many parts through. You still got to have, and we know the throughput's going to drop because it takes more steps to aqueous clean than it does solvent clean. So we know the time in the process is going to take longer, right? So if it's going to take longer, then I have to have typically a bigger piece of equipment. Now, I will say that I work with a lot of different equipment manufacturers, and there are a lot of novel pieces of equipment being designed specifically for people going from solvent to aqueous cleaning. So the equipment guys are doing a good job, but it really depends on throughput's your biggest thing. And then second thing is, the types of parts. So if I'm running a really complex part like this with all the geometries, then I may need a system that flushes parts a lot better, that has better rinsing. I may want built-in drying capability so I can flash dry these parts fast. So I don't have corrosion issues. But yeah, that's the biggest thing is throughput and the types of parts you're running for equipment. I mean, that's, there are certain things, if someone's cleaning, for example, just basic rack parts, they may be able to put in tanks, put in, water-based cleaning tanks, put their parts on racks and go through and not be an issue. But we're seeing more and more that the equipment plays a bigger role in doing this successfully.
We often hear with critical cleaning, solvent is the way to go. It's what's heavily used in that. So if a plant switches to aqueous, is there a way to test to see if they're still getting that?
So the two big areas, of course, are aerospace and medical. They, need really, really residue-free cleaning. Now, aerospace for years has done aqueous cleaning, and there are some, processes in place to do that. We're working with a customer now that does parts for Pratt & Whitney for jet engines, and they're moving from solvent to aqueous cleaning, and they have a whole lot of testing corrosion testing, residue testing on the surface. So there's a lot of tools available. We have a tool available that we use that can look at contaminants on the surface of parts. But you have to test things like corrosion. The biggest issue for those critical cleaning applications is residues. You can't have residues on the surface. And aqueous cleaning, so the cleaners themselves can leave residues. You can have the best process line there is and still have residues left behind from the cleaning chemistry. So you got to have cleaners that are more residue free, that are more free rinsing for those applications. And there are a number of ways. We have some specialized equipment we use to test, is there anything on the surface that is going to be problematic? And so that's what they're asking for, is it tells if there's anything left, because in solvent cleaning you generally have zero residue.
All tremendous information about the considerations. Not just as easy as going from solvent to aqueous.
No, it's really not. I wish it was that easy, but but what's driving all this is, and because there are plenty of what we consider the more friendly solvents to replace the ones that are under threat for regulation. But what I'm hearing from some people is that's all well and good to put in this better, safer, non-regulated solvent, but they're worried that in 5 years, the EPA is just going to start attacking those. So they're saying, hey, I just want to go ahead and just make the jump now.
Instead of doing it under a pressure of, they've got a time frame to get it done.
Right. And especially if they got to invest in equipment. So let's say someone's solvent degreasing today and they're using TCE or N-propyl bromide. And we come in and say, yep, we can put an alternate solvent cleaning process in, but you got to buy a new degreaser. You got to buy a new vacuum. You got to buy a new vapor unit, or we recommend you go to vacuum degreasing. Well, that's a huge capital cost for them. And they're thinking, okay, I do this. Am I going to have to do this 5 years from now and put in aqueous washers to do the same thing? So they only want to invest one time. They don't want to have to invest again. So a lot of people are just saying, okay, I'm just going to go ahead and make the switch to water because I don't see any downside to doing it now. Let's go ahead and start that process today.
Well, great. Well, Mike, I appreciate this. Has been very interesting and eye-opening a little bit of all that it takes. We very much appreciate you sharing all that with us today.
Oh, anytime.
The Seen in South podcast is brought to you by Hubbard-Hall. For more podcasts, visit Hubbard-Hall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media.